In this lesson, we will learn how to solve motion questions where there are multiple trips or there are multiple travelers. In this example, there are two separate travelers, Ada and Carl, who are both traveling from Townville to Villageton. We are told the speed of each traveler, and we are told that Ada arrives in Villageton 1 hour before Carl does. Our goal is to determine the distance from Townville to Villageton. So how do we begin? Well, a useful approach here is to see what word equations we can write. To do this, we should consider three possible themes: time, distance, and speed. So to begin, what kind of equation can we write that shows the relationship between Ada's travel time and Carl's travel time? Well, the question tells us that Ada arrives in Villageton 1 hour earlier than Carl does. This means that Ada's travel time was 1 hour less than Carl's travel time. So if we add 1 hour to Ada's travel time, then the two subsequent times will be equal. So this is the word equation that we can write based on travel times. What about the next theme? What sort of equation can we write based on distances? Well, since Ada and Carl are both traveling from Townville to Villageton, we can say that the distance that Ada traveled and the distance that Carl traveled must be equal. So this is the word equation we can write based on distances. What about the last theme? Can we write an equation based on speeds? Well, we are told that Ada's speed was 100 kilometers per hour and Carl's speed was 75 kilometers per hour. So we could write two equations. Ada's speed equals 100 kilometers per hour and Carl's speed equals 75 kilometers per hour. Now that we have written three word equations, which one should we use to solve the question? Well, let's use each word equation to solve the question 3 times, and then we can examine which approach is best. Let's begin with our first word equation. Our goal here is to replace Ada's travel time and Carl's travel time with algebraic expressions and then solve the resulting equation. To do this, we will use the fact that travel time is equal to distance over speed. Now, we are told that Ada's speed was 100 kilometers per hour, but we don't know the distance. In fact, the goal here is to find the distance. So let's let D represent the distance from Townville to Villageton. At this point, we can say that Ada's travel time equals the distance D divided by his speed, 100 kilometers per hour, and to this time we will add 1 so that it equals Carl's travel time. Now, since Carl's speed was 75 kilometers per hour, his travel time must equal D, the distance, divided by his speed of 75 kilometers per hour. At this point, we have an equation we can solve for D. First, we will combine the terms on the left-hand side by first rewriting 1 as 100 over 100. Now that we have common denominators, we can add the terms to get the following. From here, we can cross-multiply, then expand the left-hand side, then subtract 75D from both sides, and then divide both sides by 25 to get D equals 300. So the distance from Townville to Villageton is 300 kilometers. Okay, now let's return to our word equations and solve the same question using the word equation that says Ada's distance equals Carl's distance. To transform this into an equation with algebraic expressions, we will use the fact that distance is equal to the product of speed and time. Now we know Ada's speed, but we don't know his travel time. So let's let A equal Ada's travel time. Now, since Ada arrived in Villageton 1 hour before Carl did, we know that Carl's time is 1 hour more than Ada's travel time. This means Carl's travel time must be A plus 1. We now have enough information to rewrite each person's travel distance using algebraic expressions. Ada's distance will equal his speed of 100 kilometers per hour times his travel time of A hours. Next, since Carl's speed was 75 kilometers per hour, his travel distance will be the product of his speed, 75 kilometers per hour, and his time of A plus 1 hours. At this point, we have an equation we can solve for A. First, we will expand the right-hand side. then subtract 75a from both sides, and then divide both sides by 25 to get a equals 3. This tells us that Ada's travel time was 3 hours. At this point, we can find the distance that Ada traveled by applying the distance formula. The distance Ada traveled will equal the product of his speed of 100 kilometers per hour and his travel time of 3 hours. This equals 300, so the distance from Townville to Villageton is 300 kilometers. Alright, let's return to our word equations and solve the same question using these two word equations. To transform these into real equations, we will use the fact that speed is equal to distance over time. Now, since we are not given any information about the distance traveled or the time they spent traveling, we must assign some variables. To begin, let's let d equal the distance between Townville and Villageton. And as far as times are concerned, let's first let a equal Ada's travel time. Now, as we saw earlier, if a equals Ada's travel time, then Carl's travel time must be a plus 1. We now have enough information to rewrite each person's speed. Let's begin with Ada's speed. This will be equal to the distance d divided by Ada's travel time of a hours. This speed, we are told, is equal to 100 kilometers per hour. Now, if we take this equation and cross-multiply, we get d equals 100 times a. Next, we will work on Carl's speed. When we apply the speed formula here, we see that Carl's speed is equal to the distance d divided by his travel time of a plus 1 hours. And this speed, we are told, is equal to 75 kilometers per hour. Now, if we take this equation and cross-multiply, we get the following equation. From here, notice that our first equation is set equal to d, and the second equation is also set equal to d. As such, we can combine these two equations to write 100a is equal to 75 times a plus 1. To solve this equation for a, we can expand the right-hand side, then subtract 75a from both sides, and then divide both sides by 25 to get a equals 3. This tells us that Ada's travel time was 3 hours. So to find the distance d, we can now apply the distance formula using Ada's travel information. The distance will equal the product of Ada's speed, 100 kilometers per hour, and his travel time of 3 hours. This equals 300, so the distance once again is 300 kilometers. We have now examined 3 different ways to solve this question based on 3 different word equations. Now, which of these equations was the best one to work with? Well, let's analyze each one beginning at the top. To compare travel times, we already had the speed of each person, but we needed to assign a variable to the distance. This was very useful, since it meant the resulting equation would be in terms of d, and the goal of the question was to find the distance. What about the middle equation? To use this equation, we already had the speed of each person, but we needed to assign variable expressions to the travel times, which meant the resulting equation was in terms of Ada's travel time. Now, we were still able to solve the question using this word equation, but it took us longer to do so, because after we determined Ada's travel time, we had to then use this information to determine the distance traveled. What about the bottom equation? To use this equation, we had to assign variables to both the distance and the travel times, which meant the resulting equations had 2 variables. So, as we are considering which word equation to use, we should try to determine which equation will end up using the variable we are ultimately trying to solve for. As such, the top equation was the best equation. Okay, let's summarize. In this lesson, we learned that when tackling motion questions involving multiple trips or multiple travelers, we should first consider what word equations we can write. Then use the word equation that results in the most favorable variables. In this lesson, we will examine questions where the distance between 2 traveling objects is either shrinking or expanding. In the example shown here, Yolanda and Bob are walking towards each other, so the gap between them is shrinking. Our goal is to determine how many hours it will take for them to meet. To answer this question, let's see what has occurred after Yolanda and Bob have both traveled for 1 hour. Let's begin with the two of them in their original positions. Now after 1 hour, Yolanda will have traveled 4 miles towards Bob, since the question tells us that Yolanda's walking speed is 4 miles per hour. Similarly, after 1 hour, Bob will have traveled 3 miles towards Yolanda, since the question tells us that Bob's walking speed is 3 miles per hour. So after 1 hour, we can see that Yolanda and Bob are now 35 miles apart. In other words, the distance between them has shrunk 7 miles during 1 hour. We say that the shrink rate is 7 miles per hour, and we get this rate by adding the walking speeds of Yolanda and Bob. Now our goal is to determine how many hours it will take for them to meet. So if Yolanda and Bob were 42 miles apart when they began walking, we want to know the time it will take for the distance between them to shrink from 42 miles to 0 miles. To calculate this, we will use the time formula. So the time will equal the original separation distance of 42 miles divided by the shrink rate of 7 miles per hour. This equals 6 hours, so it will take 6 hours before Yolanda and Bob meet. Okay, now let's try another question. Here we are told that Sabby and Gwyn leave the same location at the same time and head towards Townville. Sabby travels at 40 miles per hour and Gwyn travels at 30 miles per hour, and we want to determine the distance between them after 4 hours. So once again, let's see what has occurred after they have traveled for 1 hour. Since Sabby travels at a speed of 40 miles per hour, she will have traveled 40 miles after 1 hour. Similarly, since Gwyn travels at a speed of 30 miles per hour, he will have traveled 30 miles after 1 hour. As you can see, the distance between Sabby and Gwyn is expanding since they began at the same place and after 1 hour they are no longer together. We can calculate the expansion rate by subtracting Gwyn's distance of 30 miles from Sabby's distance of 40 miles. So after 1 hour, the two of them are 10 miles apart, so we can say that the distance between them is expanding at a rate of 10 miles per hour. Now our goal is to determine the distance between Sabby and Gwyn after 4 hours. To do this, we will use the distance formula. So the distance between them after 4 hours will equal the expansion rate of 10 miles per hour multiplied by the time of 4 hours. This equals 40, so Sabby and Gwyn will be 40 miles apart after 4 hours. Okay, let's summarize. For questions with shrinking or expanding gaps, first observe what happens after 1 unit of time. Then use this information to determine the rate of expansion or shrinkage. Finally, apply this rate to the question.